Hello everyone. Today let's solve the problem number 66 plus 1, right? So what the question states here, we are given a list of digits. You can clearly see here, we are given a list of digits 1, 2, 3. You can clearly see here, right? We are given a list of digits representing a large integer. So this we will consider this one as a large integer. In this case, we'll be considering 1, 2, 3. This one 123 we will be considering here. So just keep this in mind. We are given a list of digits representing a large integer. What is our main task then here? Our main task is to increment this number by 1 and return the new list of digits. So what we need to do here, we have to increment the number by 1 and return the new list of digits. So this one as a whole, just give me a second here, 1 second. This one as a whole, we will consider 123. So here in the array we have 1, 2, 3. This one as a whole we will consider 1, 2, 3, and we have to, what we need to do, we have to increment this number by 1 and return the new list of digits. In this case, if we increment 1, 2, 3 by 1, it becomes 1, 2, 4. This one we have to return again in the form of array. This has to be 1, 2, 4. So that's what they have given in the question. So I hope the question is completely clear. Here you can clearly see output here in this case is 1, 2, 4. How we got this one? This one we considered as complete digit 1, 2, 3, which is in the array, and then we are incrementing this one by 1, nothing but in this case it will be 1, 2, 4, right? I hope this is clear. We need to return again back that one in the array, right? 1, 2 and 4. That's what we need to do here. So the array, let's go with the explanation here. The array represents the integer 1, 2, 3. Incrementing by 1 gives 1, 2, 3 plus 1, 1, 2, 4. That's what they have given. Thus the result should be 1, 2, 4, right? Same goes with the example 2 and example 3 as well. So here digits 4, 3, 2, 1. This will be 4321. When we increment this one by 1, it has to be 4322, right? 4322. So in this case, the array represents the integer 4321. Incrementing by 1 gives 4321 plus 1, nothing but 4322. Thus the result should be 4322. They have beautifully explained this one, right? So here digits 9. So in this case, you can clearly see here 9. We have to increment this one by 0. So this one we will discuss this one during the approach. So this has to give 10, and we have to display this one in the form of 1, 0 in the output, right? So explanation, the array represents the integer 9. Incrementing by 1 gives 9 plus 1, 10. Thus the result should be 1, 0, right? I hope the question is completely clear. What we need to do, that is also completely clear. First, what we will do, we will discuss the approach, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, what we'll do, we will discuss the approach. Yeah, let's discuss the approach step by step. First thing we have to keep in mind here is we will be going with the iterative reverse traversal. Just keep this in mind. We are going with the iteration or iterative reverse traversal. So I have considered the same example, the first example that they have mentioned in the question, right? So this is digits 1, 2, 3. The output that we need to get here is we will consider this one 1, 2, 3. So 1, 2, 3 plus 1, we have to increment this one and we have to get 1, 2, 4. Nothing but we need to return in the form of array like this 1, 2, 4. So output here is 1, 2, 4. Let's quickly discuss this one step by step. So first step here is we will traverse the array from the last index to the first index. Reverse iteration we are doing. So we will traverse the array from the last index to the first index. Just keep this in mind. So within this one, the first thing we need to remember here is we increment the last digit. We increment the last digit here. If it becomes less than 10, then we will return the array. So if it becomes less than 10, again I'm telling this is very important. If it is less than 10, then we will return the array. So here in this case, see 1, 2, 3 we will increment the last number, nothing but in this case it will be 4. So this is less than 4 is less than 10 in this case. So we will increment this one 1, 2, 4 within the array. Hence we got the solution here. As the same example here, add 1, nothing but 3 plus 1 is 4. Since 4 is less than 10, we will stop and we will return 1 to 4. So this is what we need the output. Output is 1 to 4. We got it here itself, right? So we got it here itself 1 to 4. So there are two more conditions we need to consider accordingly with the example 2 and example 3 they have given. So there are two more conditions. If the digit becomes 10, if the digit, if suppose 9, in the third example we have 9, right? If the digit becomes 10, we will set it to 0. We will set this one to 0 and move to the previous digit. Now we have 9. We will this one, we don't have any number here previously. So what we will do, if all the digits become 0, in this case it has become 0, we will insert 1 at the beginning. So this will be 10. Suppose if we had 999, then what we will do in this case, we will give 000 and append the 1 at the beginning. This will be 1 comma 0 comma 0 comma 0. That's what we'll be doing. This is the approach. These two steps also we have to keep this in mind. If the digits become 10, we will set it to 0 and move to the previous digit. This we have to keep in mind. And the last one, if all the digits become 0 here, we will insert 1 at the beginning. We will insert 1 at the beginning in this case, right? So I hope this is completely clear. So these are the three things you have to, at any cost, you have to keep this in mind, right? So this is the approach that we will be going with. We have went through this one step by step, right? So this is fine. Let's quickly discuss the edge cases. So I hope the approach is completely clear. Now let's discuss the approach step by step. I mean this one, edge cases step by step. So let's continue. Sorry, power cut here. So this didn't turn into next page at all, I think. So in this case, until here it is clear, I think. The last two, this one, we will discuss that one again before discussing the edge cases. I had already explained this one, but due to power cut, this one didn't turn into page 3 at all. This is fine. Let me explain this one again here. So final output we got here is 1, 2, 4. This one, I hope this is completely clear. Two more edge cases that we need to consider here. If the digit becomes 10, then we will set it to 0 and we will move to the previous digit here. This one I am telling. In this case, we have only one digit. So we will consider 0 and we will append 1 at last. So here in this case, if I consider the example 999 here, so 0 we will give 0. Again, the next digit to this one is also 0 and next digit to this one is also 0. And we will append 1 at the beginning. So this becomes 1000, right? So this one we need to consider. If the digit becomes 10, we will set it to 0 and move to the previous digit. This is one thing. The third main thing here is if all the digits become 0, then we will insert 1 at the beginning. So for this example, whatever we have considered, this we will again discuss this one during the edge case, right? So I hope this is clear, right? These are the three main points that we need to consider, and this is the approach that we'll be mainly going with. This we will see how can we articulate that one in the form of code, or how can we write that one in the form of code. Write the whatever the thought process that we went with, how can we articulate or write that one in the form of code, that we will see, right? After discussing the edge cases while writing the code. So this one, these 3 points, right? I hope the approach is completely clear. Next, what we will do, we will discuss the edge cases one by one here. In this case, we have 9, right? We have the single digit 9. So the output will be 0 initially and 1. So we are appending 1 before, right? I hope this is clear. And we have the second edge case, all 9s here. This is for the condition single digit 9. This is for the this one. This is for the condition all 9s here. In this case, 0, 0, 0. We have 1 at the beginning. We have discussed this one already, right? So this one we have middle carry. Here you can clearly see here, right? So this will be 0, 0 and we will carry 1. So we have 2 here. The third number we have. What we will do in this case, we will do 2 plus 1. If we have number, we will do 2 plus 1 in this case. So here it will be 300 in this case. So this is for the condition single digit 9. This is for the these are the 3 edge cases that we need to keep in mind. First one was for single digit 9, second one was for all 9s, and the third one was for middle carry, right? I hope all the 3 edge cases are completely clear. So this is the approach we'll be going with, and these are the edge cases that we need to keep in mind. I hope all the edge cases as well as the approach is completely clear. Now let's start writing the code. So now let's start writing the code here. First thing is we have to iterate the array from the last digit to the first accordingly with the approach that we have discussed. So for simple for loop here, for let I equals digits dot length minus 1, reverse iteration we are doing here, I greater than or equal to 0, I minus minus. This is fine. The next step, we have to increment the current digit and check if it's still less than 10 or not. So simple if condition here. So if I'll just give here this one here, digits, iterated value of the digits, if it is less than 10, then what we will do, we will return digits on this case, right? So the next step here would be, if the digits become 10, we will set it to 0 and continue the loop. If the digit becomes 10, again I'm telling, we will set this one to 0 and we will continue the loop. This we have already discussed, right? We have seen this one with the example and edge cases as well. So here let me write here iterated value of the digits. Let's initialize this one to the 0. This is fine. The final edge case here is if all the digits were 9. So we have already discussed this one, 999, we saw that one, right? We have to insert 1 at the beginning, or we have to append 1 at the beginning. Nothing but we have to insert 1 at the beginning. So we can make use of the unshift function here, unshift method right here. So digits dot unshift means it helps in adding the 1 or appending 1 at the beginning, right? So digits dot unshift of 1, let's give here. Finally we have to return the digits, right? So we have to return all the digits within the array. This is fine. So this is it for the code. Let me hit the run button. I hope this works. Let's see. So here, so yeah, you can clearly see here the sample test cases are getting passed here, right? Let me quickly hit the submit button. So here you can clearly see all the test cases are getting passed here. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written, right? So here the approach that we iterative reverse traversal. Again, I'm telling the approach that we went with here is iterative reverse traversal. You can clearly see here iterative reverse traversal. That's what we are doing here. That's what reverse iteration I said, right? Iterative reverse traversal. So overall time complexity would be, in this case, it would be big O of n. Why it is big O of n here? Because in the worst case, we know that we have to traverse the entire array once when all the digits are 9. We saw that one during the edge case as well, right? So overall time complexity would be big O of n here. So what would be the space complexity here? The overall space complexity would be big O of 1 in this case. So why it is big O of 1? Because we have to modify the array in place. We are modifying the input array in place, right? So except in the worst case where we add a single extra digit, that is for the this one worst case, right? That's the exception. So we will be modifying the input array in place. So overall space complexity would be big of 1 in this case, right? So overall time complexity would be big of n, and the space complexity would be big of 1, right? I hope the solution or code that we have written is completely clear. For now, this is it. Thanks for watching, guys.